All right, hi everybody. Thanks for coming and spending some time with us today. I am John Link, Partner Product Manager for Microsoft Discovery.
And I'm Viktor, I'm a dev lead on the project.
So today, since we only have 25 minutes with you, we've got a very simple agenda. First, I'm going to tell you about why we're excited about Microsoft Discovery, and then Viktor is going to show it to you in action. Now, with Microsoft Discovery, we're driving advances for the world of science and R&D, from chemistry and material science, to bio, drug discovery, physics, silicon design. It's an exciting field to work in. Now, before we dive into that world, let's talk a little bit about the technology that makes it possible. It should be no surprise to everyone here, we're at a real inflection point with AI. For the last couple of years, the model has been pretty clear. AI shows up as a productivity accelerator. You take a human doing a task, you add co-pilots, assistants, maybe an agent, and you get incremental gains, maybe 20, 30%. That's useful, but still linear, still bounded by human capacity. What's changing now is agency, and it's crossed a threshold. We're flipping from AI assisting work to AI performing work. Not replacing humans, but shifting the role that humans play. In this new model, you don't have one person doing a task faster. You've got teams of agents continuously, autonomously working, guided by humans. Now, R&D is not the first workflow that's gone through this inflection point. You know, software development is right in the middle of this, as you know. And if there's one thing, one learning about that transformation that we've internalized, it's that it can happen almost overnight. Now, if you take a look at this timeline here, you know, we announced GitHub Copilot back in 2021. For the past 4 years, it's evolved a lot with chat, agentic mode, agents moving to the cloud, having a gradual impact on developer productivity. However, last November, the flip happened. The release of models like Opus 4.5, GPT-5.2 added the required agency for those agents to be able to cross that inflection point. And suddenly, almost overnight, nobody's just talking about code anymore, because the agents are now the ones writing most, if not all, of the code, with developers guiding and steering the process. We believe the same thing is coming to R&D, and it is also going to happen almost overnight. If you step back for a minute, the R&D cycle looks surprisingly familiar. Reasoning, generating hypotheses, running experiments. It's not that different from how we think about design, implementation, and testing in software. And just like software, until recently, agents in R&D have mostly shown up as assistants. It helps at individual steps. It makes scientists more productive. But the human still has to run the loop. And we've seen that that model doesn't scale. In software, we cross this line where we move from AI assisting tasks to agentic systems executing whole workflows. The same thing can now happen in discovery. This is agentic discovery. Humans set the intent, the direction, and the judgment, and teams of AI agents execute that discovery loop end to end, continuously. That shift changes the bottleneck. Discovery is no longer constrained by how much exploration a human team can do. It's constrained by whether you have the right platform to run agentic systems reliably, responsibly, and at scale. And that's the point where existing tools break. Humans still have a central role, but they move from executing every individual step to providing intent and guiding direction throughout the entire process, using their own judgment and expertise. This is not removing scientists, it's amplifying scientific judgment. And this transformation is exactly why we developed Microsoft Discovery. Agentic AI gives us a fundamentally new way to work that we call frontier R&D. And the breakthrough isn't in intelligence alone, it's scale. We can now explore thousands, if not millions, of hypotheses in parallel, not by replacing people, but by letting AI agents do the exploration while humans provide the direction, the guardrails, and the judgment. We introduced this enterprise platform last year at Build in private preview, and this year we announced that we've taken it forward to general availability. We've shared here at Build demos of developing novel immersion coolants that are PFAS-free. We've shown how you can break down plastics using proteins for recycling, and more. While our enterprise capabilities are key to our customer needs, configuring Azure resources, dealing with IT compliance, can add friction for those who just want to understand what is possible in Agentic Discovery. That is why we just announced the Microsoft Discovery app, which is a complement to our core enterprise services. This is a free download that only requires a GitHub Copilot license to get started. With this app, we've now got a lightweight on-ramp to frontier R&D. Now, rather than talk about it, I'd love to hand the stage to Viktor to show it to you in action. He'll highlight some of the key capabilities that we've developed for scientific problems, like our discovery engine and our scientific bookshelf, and then I'll close things out by sharing a bit more about what our customers are actually doing in the real world today to address their own challenges. So Viktor.
Thank you, John. Switch to this machine, please. Hi, everybody. I'm Viktor, and this is Microsoft Discovery. First, I'm going to ask Discovery a scientific question right here and explain what's happening here while Discovery is answering it for us. Okay? So to get started with Discovery, you can go to our GitHub community report, Microsoft.Discovery. You can learn about the latest news, ask the question, find the link to documentation, and most importantly, find the link to our latest releases. Then download and install it from here. Okay? I already installed Discovery in this machine, so we're ready to get started. After launching Discovery, I logged in using my GitHub account right here. As John mentioned, you do not need Azure account to start with Discovery. But if you do have Azure account, you will have access to our enterprise services, such as integration with Azure HPC and Azure AI Foundry. Now, this whole user experience may look familiar to you, and this is because we built Discovery on top of Visual Studio Code, right? And GitHub Copilot to leverage power of these technologies. At the same time, we added new unique capabilities for scientific research, and I will highlight 3 of them today. First, the bookshelf, our graph-based information retrieval system. Second is Discovery engine that fully automates this scientific discovery loop, hypothesis, experimentation, reasoning. And third, the user experience specifically tailored to scientific research. And I will show all of them running here today locally in the app. But if you have Azure account, we'll also support an enterprise services running bookshelf and Discovery engine in the cloud. And you can run this version of the Discovery experience in the browser in case you don't want to install it locally. But for today, we'll just focus on the local experience because this is the easiest one to get started. Now, Discovery organizes projects into, before we do that, I will say that we're going to do the scientific research today. We're going to do computer science research. AI infrastructure is in high demand these days, and as AI engineers, sometimes we face a dilemma when we build the services. Should we host them in containers or go serverless? And instead of just trying to guess, we're going to ask a data-driven way and discover that together. Okay? So Discovery organizes information into projects. And on the Discovery app, the project corresponds to a local folder. I open the one right here. And if I look at the files, this notebook is just pop up here. It was just generated while Discovery is answering the question that we asked. But all other files, they're the system files that Discovery created when we created the project. It didn't have anything to do with the question that we're asking, with one exception, which is the bookshelf. So to start with this research, an engineer on our team pre-curated a list of 100 scientific papers on topics of AI workloads, serverless architectures, and containers. And just to give you a flavor of how that looks like, here's one example. This is a paper from Microsoft Research a few years back. Pretty detailed analysis here with some benchmarks on serverless architectures and the whole startup time and so on. And 100 papers have thousands of pages. It will take me like days, maybe weeks, to read them line by line. And this is too much to fit into a context window for a model. But instead of that, I created a bookshelf here in Discovery right here, and I indexed all these PDF files into this bookshelf. It took about 20 minutes. I did that before the demo. Doing the indexing, the PDF files were converted to Markdown files, so it's easier for the model to reason on top of them. But you can think about the bookshelf as a RAG, but with one key difference. Instead of a traditional vector store to store embeddings, we actually use the graph data structures to store entities and relationships between them. This technology called GraphRag, it was invented by Microsoft Research, and we productized it in Discovery. And It works particularly well for like deep scientific applications that in papers that have a lot of entities and complex relationships between them. And here I'm only going to use publicly available papers, but in reality, teams often decide to enrich their bookshelves with proprietary papers and knowledge so they can get answers that are specific to their organization. Let's now look at the question that we asked to the discovery. I will read part of it. So saying, hey, we're conducting an analysis on whether to use serverless function for agentic tool calling in the Microsoft Discovery platform. Currently, our agents execute their tooling in dedicated container instances. We want to determine if we can reduce the cost by switching to on-demand function execution whenever the tool call needs to be made. I've created the bookshelf. Please review the corpus of data, create a Jupyter notebooks with your findings. Be sure to show advantages, the disadvantages of user containers. Be sure to generate graphs, show resource consumption, trade-offs, price, performance, and so on. The main point here is it's not just a simple prompt. This is a pretty detailed instruction structure that you can imagine kind of as a conversation between domain experts. And we found out that we get best results from discovery when our customers use their expertise to ask these detailed questions. Before we jump into looking at the answers, I will make one meta point. We live in interesting times. Technology is advancing at unprecedented speed. Things are moving super fast. But the demos become a little bit passive, right? I remember presenting a build a few years back, and I was like constantly clicking and typing something to make the progress. But here, the flow is different now, right? We collect the data, we formulate the problem, and then we let the system do the work while we can have a nice conversation about the product. And another nice thing, interesting thing, that I actually don't have control over the precise output. Discovery is doing a pretty good job converging on the same insights, but the exact details actually vary from one run to another. So I'm going to hide the chart here, and we're going to look at the notebook that Discovery generated for us. And I'll look at the notebook the very first time together with you. So let's see what we have here. So summary of the problem, good. It said what we analyzed, also good. It collected some advantages, disadvantages of containers versus serverless architecture. Okay, important, nice. Looked into the cost model, generated some code. Okay, this is a really nice one. So looking at the percentage of duty cycle, like how often the tools are used, we'll see where the break-even point will happen. And my manager, finance, will like this kind of data. Let's see, resource consumption trade-offs. Okay, so now there's a fleet utilization we see with difference between dedicated container and serverless, and also how this can vary potentially based on the hour of the day. Okay, that's important. Then here it basically compares now the call start latency. So if we're going to spend less money on running the infrastructure, it's probably going to cost us more in performance, right? If the hardware if the servers are not ready when we want to do the tool call. So it actually compares the WAM container versus the serverless call start, which is larger. And then there's kind of a sweet spot, which is a little bit slower, but kind of probably is a good thing to do, given the saving in cost. And we ended up closing the loop here with saying again, like, okay, what's here? So hours of the day, utilization, and the difference between, if we use telemetry to feed it back to Azure, and it will be more efficient because we can predict when there will be demand, we can kind of have our infrastructure ready for that. And the overall recommendation is a hybrid execution model. And when I ran this several times, Discovery always came up with these insights, but the graphs the diesel generated were slightly different from one run to another. All right, this is pretty cool, right? This is kind of the details that we want as engineers to make a data-driven decision. And because this is a Jupyter notebook, I can tweak it if I want to change something. I can also ask Discovery to change it in the chat. But this is probably a little bit too much of the details to share with like less technical audience maybe. That's why we also ask Discovery to generate in the same prompt a one-pager executive summary. So here it is. And it showed the summary of recommendation, extracted some key data points, and then pull the main chart on the cost saving and say why the hybrid proposed approach is the best. Right? So nice. I can now share it with anybody on the team. So this is already pretty good, but I will ask Discovery to do one more thing. So I'm going to, let's go back here, open the chat again, and ask, okay, stop the current execution, keep the result, and ask Discovery to do one more thing. This question. question and answer is pretty nice, but if we really want to push frontier of R&D forward, this simple question and answer, even if it is a really good answer, that's not enough. To really push frontier of R&D, we need to fully automate this scientific discovery loop. Reasoning, hypothesis, experimentation, feeding to more reasoning, more hypothesis, experimentation, just kind of continuing. And that's exactly why we built a discovery engine, and I will show you how it works. So here we're asking Discovery, let's create an agent and task flow that can iterate on your recommendation using a scientific method investigation loop. The agent should come up with a new observation and hypothesis and a short summary, continue, right? So let's look at the agents now. We didn't talk about them yet. Discovery comes with 2 pre-built agents. You can click this edit button to see what's inside. It has name, description, tools that the agent can use, as well as a pretty detailed instruction as a markdown. All is actually markdown, and this format is fully compatible with GitHub Copilot agents. Okay. And then you can create the agents manually, you can edit them manually, or you can ask Discovery to create them for you, like we just did. Another powerful concept is tasks. So instead of asking one question at a time here, we can create one or better multiple tasks and assign them to agents, so agents can do this work in parallel. So I'll show you how that looks like. So let's say demo task as a name, TBD description for now. So here's the task, just created. It has some basic things like status, time, description, what this task is supposed to do, different states it can transition to, dependencies, so we have the trees of task, comments where humans and more often agents will add their thinking about, reasoning about the task. And the most important part is that we can assign this task to an agent, right? We can do it manually, or we can actually have Discovery assign it automatically for us, right? So this is how the Discovery engine runs. So it looks at all tasks that needs to be executed, then it looks at all available agents and does this matching. Agents pick up the task, does it work, and work the tooling if necessary, gets back the results and adds them to the comments. And then if the agent cannot answer the task completely, it can create new tasks for itself or some other agents like delegation, subtasking. Then the Discovery engine monitors the task, this new task, and it will be looking at the results. It will also be looking at the model confidence scores. It will decide if this direction of the research of exploration is not promising, it will abandon the task. And if the other direction of exploration and research is promising, it will actually start continue assigning tasks to the agents. And this is really powerful because this whole loop can run automatically for hours, sometimes even days, and get us really, really deep insights. So let's see here. So Discovery now is still working on creating this task for us. It may take a moment to complete. I will show you here how that looks like when it is already created. So like here, we can look at the task that Discovery can create with a description, assign it to the agent, and then the new agent that it created specific to our question that we asked, right? So let's go back here. All right, now I actually discovered in the question that asked live, it was able to create the task and the agent assign things. So this whole process will take some time to complete, so we're not going to wait for it live. And instead, we'll jump ahead to some results of running similar discovery process in other domains like chemistry and material science. Before we do that, I want to briefly summarize what we saw in this live demo. In about 15 minutes, we gained deep insights about containers and serverless architectures when related to AI workflows. Discovery was able to analyze 100 scientific papers, extracted deep insights from that, wrote a Jupyter notebook for us with a lot of technical details. Actually, it was able to create also the executive summary one-pager, and it was able to start the next execution cycle for this continuous discovery loop. All this power is available for you today. I cannot wait to see what you will discover next. So thank you, guys. And back to you, John.
Now, can you pull up the HTML reports we've got here?
Yeah.
We've got them right there.
Yep.
Yeah, so as Viktor said, you've seen it's real, it's live, it works. That discovery engine, this is the cognitive layer that we've built that we can use to drive actual customer outcomes. I'm going to show you what a couple of those look like. If we could actually, stay on this one right here. The first thing I'm going to show you actually is that discovery engine in action. What does that look like? When you've got sets of agents, You've got an agent that starts. If we're going to follow the scientific process, you're going to follow different pathways, try different hypotheses. I need to speed this up to 200x just to show you really what that looks like. As it was solving a scientific research problem, it's creating new agents, following new paths, getting to different outcomes until ultimately it can come back and say that I've gathered all the information I need to meet my own internal OKRs and guidelines, and I've closed out that task that I'm working on. So how do we use this? One of our customers, 𝗦𝗲𝗀𝗀𝗀𝗀, who we've been working with during private preview, worked with us to solve one of their own problems. Now the interesting thing about science, we think about R&D from knowledge to outcomes. We actually think about starting left. What happens when you actually need to understand where to do your R&D? And that starts with business. So we worked with them to develop a set of business agents that we added. It's just another set of agents to add to that discovery engine to do the work of saying, where should I invest my R&D dollars? And this is the answer that they got back: heat transfer fluids for semiconductors. In a world of explosion of data centers, that makes a lot of sense. And they've got all of the data right here that we can look and see, give us the outcomes of what makes sense for them, look at the other possibilities that they could have looked into. That's great. So they say that I should invest in heat transfer fluids. Now I need to understand how I actually go about building that product. So just like Viktor asked a research question informed by the bookshelf, they do that, but informed by all their own proprietary data, along with all of the relevant knowledge from this area. And we say, okay, great. If I want to develop a new heat transfer fluid, here's the most important properties for me. Here are the things that matter. I can look at those top properties. I can look at all the properties, all of the rest of the information, this detailed matrix of what to do. But knowledge is just the beginning. It's not enough to be informed about what you want to do. You need a system that can really execute. And that is what we do next then, is we then have these agents actually drive the full research process for us. This can take weeks, even months, but it vastly accelerates the time to outcome for all of these customers. Now for them here, we can see that we actually identified 4 new candidates for heat transfer fluids with 𝗦𝗀𝗀𝗀𝗀. And we can scroll through here and see that actually we've saved the full computational plan. So you can look and see the golden path that we took to get there. Reproducibility, very important for the world of science. I can scroll down through a lot of detail here. This is great. I love seeing these kind of charts that show that we're actually following a smart scientific process. We're doing multi-parameter optimization, not just brute force dumb optimizing for one single property. You need to actually get to a real outcome that you can have faith in here. And I think one other interesting thing I love showing off down here is when we get to the end, it even tells us suggested next steps, both in silico that we continue to do on the Discovery platform, or then transitioning to the actual wet lab. So really great capabilities of what we can do for customers. Now, if we can switch back to the other screen here on the laptop, this is not just 𝗦𝗀𝗀𝗀𝗀𝗀. We've got a whole fleet of customers we've been working with and looking forward to even more here as we go out to general availability. If you go search the web after build today, we've got a lot of great blogs and press releases from some of our customers like BHP, Cambridge Consultants, Causally, In Silico Trials, and many others that you see up here. With that, we thank you for spending time with us today. If you're interested in enterprise solutions that take advantage of the power of Azure, you can learn more at aka.ms/Microsoft Discovery Docs. And if you want to try out the local app, you can find it at our Discovery GitHub repo. And as you've likely seen in other sessions, we'd love your feedback if you're willing to fill out a quick survey. And thank you very much for spending time with us.
Thank you.